Hi all, today in this video we are going to cover topic like how to create a Spring Boot application and connect with the MongoDB database. We are going to cover CRUD operations using Spring Boot REST API and MongoDB. The points which we are going to cover in sequence are like first we will see the introduction. Next we are going to create a backend database and collection in MongoDB using MongoDB Compass. MongoDB Compass is a graphical user interface in MongoDB database for MongoDB database. Next, we are going to configure our MongoDB database related attributes in our configuration Spring backend configuration, which is application.properties file. Next, we are going to implement CRUD functionality to store and fetch data from the MongoDB database. And finally, we are going to test our APIs using Postman and verify the response data in Postman as well as in MongoDB database collections. So let us start with our first point by creating a database and collection in MongoDB, and for that we are going to use Compass, MongoDB Compass. We have two options, like we can either use MongoDB Compass or command line interface, which is a MongoDB shell. So for in this video we are going to use MongoDB Compass. So let me open the MongoDB Compass. This is our MongoDB Compass. Fine. This is the default URL. We can connect it. So it is connected. Now we can see these are the default databases like admin, config, and local. And if we want to create a new database, we can click on plus button, and it will ask for the database name. We can give our database name, like let's say department master, and here we can give our collection. So this is a MongoDB database, so hence we are not going to give the table name and other because it will ask for the collection, and as it is a document oriented database, so everything will be considered in the form of collection and documents, not in the form of table, columns, and rows, because it is a schema less and document oriented non-structured database. So here we can give our collection name as a departments, and we can click on create database. Okay, fine. We have created our database with name department underscore master, and our collection is a departments. Fine. Now let us create our Spring Boot application. Let me open the STS. So here we need to give our workspace, and we can click on launch. Here we can choose this third option, which is create new Spring starter project. We can name our application, let's department underscore service hyphen service. We can give type, build type as a Maven, packaging as a jar, Java version 17 we are going to use, and here we can mention group as an com.department, and artifact ID we will keep as is, which is department hyphen service. Here for description we can mention like department service application, and for the package we can mention com.department. We can cross verify it once and click on next. Here we need to give our dependency, what all dependency we require. First we need Spring Web, next we need MongoDB, Spring Data MongoDB, next we need Lombac. That's it. These are all the dependencies we require. We can click on next and click on finish. Now we can see the project is created with all the default files and folders. If we click on form.xml file, so it will show us all the dependencies which we have just added, like Spring Data MongoDB, Spring Web, and this is the Lombac dependency. Fine. Now So this is the dependency, like this is the Spring Data MongoDB through which we can connect to the MongoDB database, and Spring Web is a dependency which is required to create our web controllers like REST controller, and we can make use of annotations within this like get mapping, post mapping, and there are other annotations as well, and stereotype annotations we can make use of. And with the lombac we can remove the boilerplate code and use the getter setters provided by this lombac. Fine. Next thing, like we can build our application using Spring Boot Maven install command. Yes, we can say our build is success. Now let us run our application using command using option run as Spring Boot application. Now you can see our application is running fine on port 8080, which is the default port. Now now our application is it's a build success and is running fine as expected. Now let us configure our database related stuff for MongoDB in our application.properties file. First we can change our port. We can keep as is, but we can change this port, and this port number we can make it like 8087. Next thing, like we can add our database related spring.data dot mongodb dot, first we can mention host, which is a local host. Similar way we can add port, and port is like 27017. If we go to here, like we have connected, this is the port 27017, and the username and password is optional, so we can give it if we have set it, or we can in this video we are not going to provide username and password as it is an optional. Now next thing, like we can add mongodb dot URI, and here we need to mention our URI like MongoDB, and here localhost and port number, which is a 27017, and we need to provide our actual database name, which is like department underscore service. Let us cross check what is our database name. It's a department under master. Department under master. Fine. Now here we need to provide one more thing, like here we have to mention the database, and database is our department underscore master. So this is the database and this is the URI. Fine. Now we are done with our configuration part. Now let us create the packages, and okay, first we can create our document package. Next we can create our service package. Next we can create a repository, and finally we can add it's a repository. It has added, we need to delete it because it is we need to create a package, not class. It's a repository, and finally we are going to create our controller package. Fine, so we have created all the required packages. Now let us add the respective components and interfaces within this. Like first we can create our document name, and our document is department document class, and here we can annotate it with document, and here we can mention what collection we are going to use. Like here our collection name, here this is our database and this is the collection name, which is the department. We need to provide the same name at here, departments. Fine, now inside this we can add our fields. Like let's say first is a private string id, next is a private name, private string name. Next we can add private string company, and finally we can add private string city. Here we can add our id annotation. That's it. And here we can add all constructors, no all constructors, data, and builder. So all these annotations are available in our Lombac package. So with this we are done with our document, and in relational database we call it like entity, but here this is the document. Now we can create our repository interface with name department repository, and here we can extend. Now here first of all we need to annotate it with using a repository, and here we can extend Mongo repository. Here we can mention our document, which is a department, and this is the data type of our primary key. We can add the import for department. Fine, we are done with our repository. Now let us add the service part. First we can add our service interface with name department service, and here we can mention all the methods which we are going to use. Like first method is a get all departments, which is a returning list of departments. Next find department by id, and here we can pass the id. Next, like we can mention one method like save department, and here we can pass the input department which need to be inserted into the database. Similar way we can add one more method for update department. and to update department we are going to pass the id attribute as well along with the actual data which need to be updated. So this is the modified data in modified input data which will be updated against this id attribute, which is the input id, and finally it will return the department. Now similar way we can use delete API delete function. Here we can mention string as a return type and we can save it. Fine. Now let us add our service implementer class with name department service IMPL, and we need to provide all the implementations. First we need to annotate it using service stereotype annotation. Next we need to implement department service, and we need to provide all the unimplemented method we need to add it. Now this is the default implementation for all the methods available in the interface. Now we need to provide actual implementation for all these one by one. Let's say we can first inject our department repository into this service so that we can call the respective methods from this repository and get the expected result. Fine. Now here we can call return repository.find all. This will return all the departments. Next we can call return find by id, and here this will return the optional, and we can call get on this. Fine. Next we will call, we need to save this, so we can call save, and this is the input department which need to be saved into the database. Similar way we can update by calling the save method on department repository, and here we can pass this. Okay, so now this id attribute we can pass into the controller, not at service level, and we will modify the object and pass the modified object to the service to the repository. So we can remove this id part and we can add it into the controller. So let us remove from the interface as well. Fine, we can save it. Now we are done with our update method. Similar way we need to provide implementation for delete method, and this is our delete method. So delete repository is returning like void, so we can return some string on post successful deletion, like department is deleted successfully. This message will get returned post successful deletion. That's it about our service implementer class. Now let us create our controller. So we can name our controller like department controller, and here we can annotate it using res controller, and we are going to inject our department service into the department controller. Next we are going to add get mapping. So this is our first API, and here we need to provide the endpoint like it is for department, so we can give departments, and here we can return list of department, which is a return type, and the method name should be get all departments. We don't require any input it here, and here we can call the method on this service so that we will get all the list of departments, and this is the method. You can save it, department, and we can add the imports for these two. Fine. So here we can use a response entity and wrap our return type into this, and here also we need to, into the return statement, we need to call response entity dot OK, and here we can wrap this our return type object into that. We can add the import for this response entity. Fine, we are done with our first get mapping method. Now let us add next get mapping method, like it will return based on the department ID, and here instead of list it will return only a particular individual department based on get department, we can say by ID, and here we need to provide the ID, and same we need to call the respective method on service like find department by ID, and here we can provide this ID and complete this bracket. Fine, you can save this. So we are done with our second get mapping. Now we can call our post mapping to insert our department object into the database, and for post mapping we don't require the ID. Now here we can call this like create department, and we need to add request body at here, and for request body we need to pass the input department which need to be updated into the, which need to be inserted into the database. Fine, this is the department object, input department object, which will get saved into the database, and we need to call save department and pass this input department to this save department method, and with this like it will return the department, respective department. It will create a department for the input department. Fine. So for this get department by ID we need to add here like path variable annotation, and here we can mention this ID. Fine, we can save it. Now similar way we can add one more method which is like patch mapping to update our department into the database, and here we need to provide the ID part as well along with the actual object which need to be updated. We can change this to update department, and this is the request body, and we need to pass one more input field which is the id, and here we can call this update department, and we need to provide import for this patch mapping. Fine. So what we are going to do it here, like this is the id we are going to pass, and this is the update department method, and here we are going to pass the actual modified object, uh, and this is the id. Against this id, this object will get modified, and finally it will return the modified object from the database. That's it. Now this is about the update or patch mapping. Next we can add the delete mapping, and here for delete mapping our return type is a string, and we don't require the actual body, rather than just id is enough. And here for deleting the object, we need to first get the object of this department from the database. Let's say dept object, and here we can call this find by id method, so that we will get the existing object from the database. And here we can check if department object is not null, then we can call this method for deleting this object from the database. And here we need to store the returning message into some variable. So we can create one string variable, and inside this variable we need to store the message which is getting returned from this delete method, and we need to pass this delete message. Fine. Finally this message will get returned. What we have done, like here this delete department method is returning this string post successful deletion of the department. So we need to capture this string into this delete message variable, and finally we are going to return this delete message which is indicating the successful deletion of the department. Fine. So we are done with our all the CRUD API implementation part. So now let us test our CRUD APIs. Okay. So fine. Now if you look at the repository part, like here uh, we have these many fields, right? And find by id we have used, but what if we have other attributes like name, company, and city? If we want to search by any of these, how can we do that? Like for that, like we need to write some query it here. Like let's say we can first add our let's say we can cover only a single for name, so accordingly you can add for company and city, or it is a in similar fashion you can add for the rest of the fields. We can check for any of the one, like let us take an example of name and add the query find by query. So here this is the query, and inside this we can add name, and for name This is the zeroth index parameter. We can have multiple parameters, like this is for first, next for 1, 0 is for first parameter, 1 for next parameter. Likewise we can keep on adding. So right now we are covering only name, so we are adding only one parameter. Fine. Now below this we can add our list of department, which will get returned, and the method name will be find by name. This is a custom method we are creating so that it will return all the matching records which are matching to this name from the database. And we need to add the import for this and for list as well. Fine. So what we have done, this is the query and this is the input name parameter at the 0th index. We can capture this parameter and pass it at here, and based on this name it will return all the matching department or objects or documents which are available in the MongoDB database. Fine. Now let us add the similar way in our service interface. This is for department by ID, and we can add department by name, and here we can add our name attribute. Fine, we can save it. And in our department service implementer class we need to provide the implementation as well, like let's say this is for ID, we can add it here. Find department by name, and here we can mention the name instead of ID, and same we can pass it here. And so here it is returning the list, so we need to mention the list of department as a return type it here. And here this is returning list, or else we can say null in case of find by, we can say it should be name. Fine. So a repository, it's a find by name, and this is the string. Fine. And same we have added in our interface. Okay, so here find department by name, and this should be returning list of department, not just a single department. Fine, seems good. Now we can, here we can call the method name, which is find okay, find by name. This is the method we can call. Okay, so this is the repository, and here we can call find by name, which is returning list of department. In this name we are going to pass. Now we need to check. Fine, seems good. Or we can Fine. So this will basically return the list of department on basis of what department name we are passing. So finally we can add our controller part for this, and here we can add similar way, get department by ID. Here this is for departments, and here we need to change some endpoint. It should not be similar to this. Now here this is the name, and here we can mention it's a slash name, and we can pass the placeholder it here, and we can change this method name as an get department by name. Here we need to change the return type as an it is returning all the matching department, so it should be returning list of department. And here instead of ID we can say it's a name, and same we can mention it here, and can copy, and so here we can call instead of find department by ID we can call find department by name, and this is the input name against which it will return all the matching department and return it. Fine, you can save it. So we have covered all the APIs. So this is for name. So if you want to add any other like company, city, and if you have any other fields, so accordingly you can add. So this is the one option of adding the query, and we have other options like adding the reg expression or criteria query, and we can use any of the option and achieve this functionality. Fine. So we are done with our all the CRUD operations. Now let us test our functionality. So first of all we need to build this because we have added a lot of code. Now let us build it. Yes, our build is success. Now let us run this using run as Spring Boot application. Fine. So now let us do one thing. So on the database side we have created this database, and this is the collection. Now we can open the postman and verify all the APIs one by one. First of all we can check for get methods. Let's say ours is a department, and here we can use JSON, and we can click on send. So here we need to provide the same port what we are using. It's 8087. So we need to give 8087, and the endpoint what endpoint we are using, so the same we need to enter it here like departments. Now it is showing the empty record because in our database we do not have any documents or record as of now. So let us add one record by using the post method, and here we can enter inside body. We can add one record. Let's say first is ID, and here no, not first ID will get created. We can add name, and here we can mention the name as the, let's say, sales department name. Next we can mention company, let's say TCS, and here we can mention the city. Let's say it's a Mumbai, and let us check by adding this. Now we need to use the post method because we are going to add this record into the database. So make sure you are using the post HTTP method. Fine, we can see the document is created with this and the ID is generated. Now if you want to cross check in database, we can click on this is our collection, and if you click on find, you can see the same record is added into the database. Fine, so this is about addition of first record. Let us add one more record, like let's say operations department, and here we can add Accenture, and this is for Pune. Fine, now let us check by calling the get method. Now it should show two records in get method, which is as expected. Now let us check into the database. Fine, we have two record in place as expected. Now let us do one thing, like we have one more APIs, let this is the ID, find by ID, get department by ID. Fine, so we need to pass this ID, and accordingly the particular ID department object will get returned. Now it is returning all the list of departments, right? So if we pass this ID, it should return the particular object, not the list. Yes, fine, it is returning. So with this, like we have tested our this API. Now let us check for the name as well. So let us check, we can, what all names we have, we can call it. Fine, we can call pass the sales and check. And here whenever we pass the name, so here we have changed to this endpoint, we need to add a name, and after that actual name of the department. This is the name endpoint, and this is the actual name placeholder. Fine, value for the placeholder. Now you can see it is returning the list of object. So for name, it can, there can be multiple documents available with the sales department, so we are returning the list of objects, which is as expected. Fine, now let us check for our patch mapping. Now for patch mapping, so for updation we are going to use this patch http method, and here uh, we need to input two parameters. Like for patch method, this is our patch mapping, and for here first is ID input and department and ID both need to be passed as an input. So let us check what is the ID name. So this is the ID, we can copy and add it this, and we need to get the modify the existing object, because that entry we are going to save into the database. Now this is the existing entry. Now let us modify it, like let's say operations. Instead of operations we can say management, and instead of Accenture we can say uh, take M, and here for instead of Pune we can say Bangalore, and we can send it. Now we can see the record is updated successfully with the management and all these new entries. So if you want to cross check in by calling the get mapping, so we can see this is showing the updated record. And again if we cross check in database, so right now it is showing the earlier record. If we refresh it, now it is showing the latest record which we have just updated. Now similar way we can check for our last API, which is a delete mapping. For that we can use delete HTTP mapping, and for deleting the object we just require the ID, not the object. So let us check. So we can use this ID, copy, and we can pass it here after departments endpoint, and we can send. Fine, now it is showing the message department is deleted successfully, which we are returning from our service level depart after post successful deletion of the department. So this message will get returned when the department is deleted from the database, and same it is returning. So with this, so let us check into the on the database side. Yes, fine, the second record is deleted successfully. So with this, we have covered all the points which we have discussed before we start this video, and what all points we have promised we have implemented and see though all those running. So thank you so much for watching this video. I will request you to please like and subscribe this video. Thank you so much.